so where did we stop? Okay, show seats, and we showed seats. Oh, right, errors. Couldn't match type, expected type seats, actual type. Interesting. Okay, so we need to put array somewhere. Here, right? Array. It's here. Where? In ASOX seats. Expected type seats. What list of seats doesn't make sense at all? ASOX takes an array, returns the list. Expected type seats. Actual type is doesn't make sense. Seat step. Oh, right, because I put. Oh, okay, yeah, makes sense. Because we generalize, so we need seats to put here, and actually everywhere. Like for example, num occupied seats, but also x seat. I don't know. Let's say it should be num occupied. So I don't quite understand what should I do. How to? I need to call it. Occupied around. Occupied neighbors. Num oc. Sorry, I can't think of better name. Oc. Oh, nice. Main example. 0 again. Okay. So we have 3 unoccupied and okay, it's better now because it's not better. We actually need right now to understand what happens. So we want to have we want to check seat step for specific seats. Cool. So what we can do here is, since we have seats array, we don't actually have it, right? Yeah, right. But I believe we can easily just insert the code and should be fine. Oh, wait. Yeah, right. Insert code from Vim. Okay, I just hope it will work. How do you expect it to work? I don't know. Yeah. Okay, let's use breakpoints then. So what we want to have is seats array, right? So what we will do, we will have breakpoint at 16. Okay. Break 16. Continue, or rather run, or main. Yeah, right. main example. Okay, so seeds rate right now is 0. Seed states. Yeah, so what we want to do is forcing seed states is quite painful. So what we will do is, let's say, let state to be, we want to take drop to the first two states and take one head from seeds states, but there is no, right? So we are doing step seeds row. Okay. I'm not sure 15 why we are here. Oh yeah, because we are evaluating. Okay, so let's say actually breakpoint 6, wait, 16, right? Okay, breakpoint 17 maybe. Yes, that's hard because it's functional programming, so even though we are on the 16 line, our seeds array, for example, it's not completed yet, so but at least we will have it in scope. Wait, what happened? I had a breakpoint at, oh wait, so it's, is it, am I allowed to use states? Not in scope. Okay, so once more, break 17 and main example. Nice, we have seed states. Then we have state. Couldn't much. Okay, fair. Yeah, because we need first drop 2, then head. Nice. So our state is what's happening? Why? Because we reached the line. Cool. We have state. So show state. Show seeds. Right. Let's also put strlen. Okay, we have the second state. It's already too much, so let's analyze the second state. This one with all occupied, right? So now when we have state, what we want to do is to seed step one particular seed. Seed step, we have state, and our particular is first row. First row, third column, and we have such seed here, and in return we have occupied. However, what we have to do is to empty this because we have 4 around. So now we can actually do debugging, I guess. Like I want to know what is num occupied. So I guess what we'll do is go to breakpoint 29. Cool. Now we can force num occupied, and it will be 3 for some reason, right? Which is interesting. So num occupied neighbors. Let's see whether neighbors actually works. Neighbors 1 3 1 2 2 2 0 3. Wow. No, it's fine, right? No, it returns 6. What? How? Wow! I'm so dumb. Oh, uh, because I excluded when dx equals 1 and dy equals 1, and we still need them. So what we actually want to do here is we want at least dx not be 0 or dy not be 0. That's our proper filtering. Yeah. Oh, I'm so dumb. Yeah. Okay. Breakpoints. How to finish? Or what should we stop? Stop. List break back. Go back in history. Break. Continue. Delete. Force forward history. Sprint. Step. Local. Step. No. Abandon. Yeah. Cool. So now. Wait. How to unset all set points? Delete all. Cool. Abandon. Main. Because I need to reload, right? Still 0, but at least we got the third step correct. The fourth step is correct. The fifth step is also correct. But still, for some reason, we have 0. How so? Uncarry. Probably something with. Wait, so drop while. Yeah, drop while not equal, because we want to have actually. Finally. 37, cool. My puzzle input. Okay. Wait. Alright, I need to reload. Wait. Doesn't look that great, right? Wait. What if our puzzle input is actually okay? But question, why so long? Should be trivial. I don't like this. So even though map is it's not so big to compute like few seconds. So what's happening probably is the fact that we are recreating array each step. I think that what makes the problem. Because finding neighbors is not hard. Computing the next step is not hard. So I believe the only thing that can slow down is actually this stuff. How can we speed up? Let's just check whether the result is correct. Yeah, it's correct, but yeah, the performance is not great at all. Succeeds bounds. How can we rewrite this function step? Basically, we have map, but the problem is that it's not just fmap. We also want to include indexes. indices, which is make it harder. And unfortunately, there is accum array. Element in range of list array x map. There is x map, but that's not what we want. Maybe accum would be better, but accum array. Whoa. So we can give an array, give results, and give it back. But we don't need to fold. We only need to map. Okay, so no. Using list would be bad because we will need to index by the list, which is as well not good. Oh wait, there is one. No. So comparing arrays should be linear, so it shouldn't take as much time, right? But iterating through array is like computing new elements is also linear. So yeah, okay. What we can do is what we could have done is to indicate that the change has been made in the set, in the step for each seed, but then checking whether is there some change would take linear time as well. So I don't think how. Okay, it's linear time, but constant would be much lower because we don't need to iterate through all array to understand that change has been made. But same reason for array, we don't need to iterate through all entire arrays to understand that they are not equal. So that's not an argument. So yeah, I think the bottleneck here is to converting from array to list and back. How can we do it better? So I guess array accumulator array might be the way to go here. So basically what we need to ignore an element and just return the result. So basically accum array const our function like doesn't matter which element. Let's actually do void just for fun and define. Yeah, accum. Oh, actually there is accum, which is even better. Oh really? Wait, accum also takes list, so it's not better. But at least we modify an existing array. So wait, why we are modifying the existing array? Wait, so accum can be rewritten as just like a no input list, a function that ignores the element from the list and just maps array. The question is that we need indices, right? So we actually need that list. Oh, that's hard. Yeah, let's Google. I'm perplexed. Haskell map array with indices. Accum, okay, incremental array updates. Accum f takes an array and association list and accumulates pairs from the list into array with accumulating function f. So it's not actually fold, it's sort of. Oh, it's updating the array. Cool, 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 cool. Yeah, it's accum array. So let's also say what's accum array. Accum array is E range B is that I don't understand the array B range B IZ. What's that? Yeah, I don't know what's that. Accum array. Accum array function deals with repeated indices in the association list using accumulating function which combines the values of association with the same index. Okay, so I see, and we have, okay, I believe it can help accum, right? So what we will need to do is to just we have a list, right? We have a socks, and basically what we what's the difference between accum and accum array? What should I use? I don't understand why should you provide bounds of array here? Why not just do accum as here? Oh, because there is no input array here. Okay, yeah. Accum NK. Wait. Deals with repeated indices in the association list using accumulating function. Okay, so accum array basically is different from list array in the sense that it has accumulating function. But accum doesn't. It just takes pairs from the list and updates an existing array. So this sounds like what we want. Accum. Okay, accum. Bounds seed. Socks. That's good. Seed step. Yes, sounds good. Yeah. So the only thing that we need to define a function like constant something. So we don't have index element. Yeah, so we actually drop. So it would be just const. Const it. Wow, interesting. Yeah, so we doesn't care about first argument and just return the second. This is the list, and we should put seeds array here. How does it work? Wait, it's bad as well. Maybe I'm too strict, and actually even in other languages it will take much less. Oh, at the same time, I mean. Yeah, that's really suspicious, right? How many lines? We have 100 lines, right? Oh, 90 in the width. Oh, and we are doing this a lot of times, right? Yeah, actually. Okay, fine. So previous, yeah, and previous did like the same. So okay, forget about Akim. Doesn't help. The problem here is that you have a lot of iterations to make until it gets actually stabilized. Okay, so part 2. As soon as people start to arrive, you realize your mistake. People don't just care. They don't just care. Oh, actually, I want to look at my title. Advanced of Day 11. Nice. As soon as people arrive, you realize your mistake. People don't just care about adjacent seats. They care about the first seat they can see in each of these 8 directions. Now, instead of considering just the 8 immediately adjacent seats, consider the first seat in each of the 8 directions. Wow! For example, the empty seat below would see 8 occupied seats. 1, 2, 3. Oh, basically like a queen, right? The leftmost empty seat below would only see 1 empty seat, but cannot see any of the occupied ones. Okay. Wait. 1 empty seat. Oh, okay. So empty seat is still blockading occupied seat. Yeah, understand. Also, people seem to be more tolerant than you expected. It now takes 5 or more visible occupied seats for an occupied seat to become empty, rather than 4 or more from the previous rules. The other rules still apply. Empty seats that see no occupied seats become occupied. Seats matching no rule don't change, and floor never changes. Given the same starting layer, how many seats end up occupied? Yeah, should be easy for us to implement. So now we have seat step and it should be different. Basically no, what should be different is num occupied. Yes, and num occupied now. Yeah, and we have seats. Oh, actually, yeah. So we give int. Why do we give char here? Yeah, seat is not used at all here. Yeah, let's return to main. Num occupied. We don't need that. X. Okay. Does it work? Yeah, still works. So let's copy again. Okay, so now we give coordinates, we need number of occupied. So we need to find the first seat in any direction. And if we don't find the seat, that's fine as well. That's interesting. But quite easy to do. So what we'll have is 8 infinite arrays, and we take while they are in the coordinates. Floor doesn't stop. Okay. Interesting. Okay, so instead of neighbors, we still use these coordinates. No. Okay. Now we will have directions. We don't really need for the directions is one step to go, like -1 -1 or 1 -1 and so on. So it will be just dx dy. Yeah, that's yeah. No, actually, yeah, filtering rule should be the same. So for each direction we will have an infinite list of of seed coordinates, and we will take from that list till to first. Oh, let's say we cannot say drop while something, because no, we actually can drop. No, we cannot. You cannot say drop all the floor, because the floor can be infinite. So what we need to say is take only those coordinates that are in bounds, and we actually have in bounds function, so it will be really easy to implement. Yeah, and we need to do this for every direction. We say ix. Can we? No, I guess we cannot sum pairs, but we have a b functor. And we can use bmap to do plus. Map directions. Okay. So we need to iterate. We don't need to start with okay, we can drop. Just for simplicity, we say the first element will be ix, but then we immediately say tail to drop ix, and we using function bmap plus plus. So bmap plus plus, what it does to a pair, it pluses left sides and pluses right sides. Bmap ix iterate tail. So now here we have an infinite array, and what we need to do is take while the coordinates are in range, right? And in range, in range again. We need range, which is bounds of the array. Take while a wait. A in range of bounds of the seeds. Okay. have take while, but we need to find whether the first seed is. So we will have drop while floor. Wow, that's actually quite interesting idea. So what we are doing is having multiple take whiles and drop whiles. Drop while. And so it's like pipes. And the thing, it's lazy pipes. So the down take while won't take all elements. It will take only enough elements that satisfies drop while, or rather take while that will be upper. So we are drop while floor, and so floor is lava, but also floor is a dot. So we drop all the dots, and here we can come up with an empty list, and it will be empty if there are no seeds. So what we have is maybe to list. Yeah, it's in data maybe. Oh wait, a list to maybe. List to maybe, and we want to use fmap for checking. Actually, we want to use maybe because maybe also provides a default value, maybe, and because here we use number of occupied, right? So we want return 1 or 0 depending on whether seat is occupied or not. So we actually can just say filter by something. No. So list is maybe is perfect because it takes the first element. That's precisely what we need. And if there is no such element, we use maybe, and default value is 0. But if actually there is some value, what we want to do here is to compare it to so it should be 1 if it's occupied. So what's interesting, whether I can convert bool to int. So it's enum and or ord. So enum to enum from enum. Cool. From enum allows you to convert any to int. And ord is just comparing, right? Yeah, so no int. So from enum. Cool. And it will be sum. Honestly, so proud of this function. Okay. Couldn't match type int with integer to integer. Expected type in. Ha! Wow. In the second argument. Oh, right. So. Yeah, because me. Right. So directions. We have one direction. So iterate should take. Yeah. That's completely fine, I guess. So we have ix and we want. So we have direction, right? So what we want here to do is to do plus direction. Yeah, I guess it would be hard to do, so let's just say direction and wait, bmap direction. Oh, I see. So we actually cannot do it. Can I lift bfunctor, something like that? Data bfunctor. Yeah, import data bfunctor and bfunctor. Okay, there is no such function. Okay, so let's say it's not direction, dy and dx, and we say plus dy plus dx, and we start with x. Yeah, that's fine. Doesn't matter. We don't need ix, right? Since we just can yx and it will be iterate. No, actually, yes, that was bad idea. Because iterate, right? Iterate not working on ix, it works on many stuff. So 43, I guess, as yeah, closing the function. Couldn't match expected char with actual int. Why would you expect a char? Oh, here I see. In the second argument of iterate, namely ix. Wait, I don't. Right. So we need to convert coordinates into characters at some point, and it will be here because after we check for coordinates we don't need them. So what we'll do here is to sits array. Yeah, nice. 23. I don't know whether it's true. Let's see. 26. Wait. 23. 26. I guess we need to do the same as previously. Don't put states to understand what was the problem. So listo, maybe let's drop while floor. That's perfectly fine. Oh, right, because I forgot to update. We have change of rules. 5 or more, right? Yeah, now it's 26. Nice. So main task. Sounds like one more star to me. Sounds like what was special about this? Not much, because I've already programmed life, a game of life, and it's very similar. Interesting thing about Haskell that you can program infinite, the game of life on infinite board, and then you will have infinite board. You will operate on infinite board, but when you try to display, you can just cut off, like say take 100, and even though all of your operations are working on the infinite board, it will calculate only necessary amount based on how many cells are you displaying. Would it work here? I think not, because of the rule. Because especially when you need to, I think on the common task it will work, because you only look at neighbor cells. Yeah, but when you're looking, you would need to look through all the space. Okay, so what's interesting? Okay, no, Accumulate wasn't interested at all. Take wild directions in range, show hits. Debugging, but yeah. Yes, that may be interesting. Yeah. So, because it's interpreter, so during debugging we called the function and it stopped at the breakpoint, even though originally this function wouldn't have been called. So I guess that's quite nice. I don't know whether other debuggers has such ability. But yeah, it's just simple stuff, not challenging at all. Yeah, I guess about Advent, the challenging part is that you need to do it every day, and I have 7 more tasks to go, so nothing really special about this. Rain risk. Your ferry made decent progress towards the island, but the storm came in faster than anyone expected. The ferry needs to take evasive actions. Unfortunately, the ship's navigation computer seems to be malfunctioning. Rather than giving a route directly to safety, it produced extremely circuitous circuitous. Wait. What? Circuit? Is it like loop? Circuitous. Окольная, окружная. Okay, I see. Circular, sort of. From the word circus or the word circle. Oh, maybe circus is the word coming from circle. Or opposite. When the captain uses PI system to ask if anyone can help, you can quickly volunteer. Public address. Okay. The navigation instructions your puzzle input consist of a sequence of single character actions paired with integer input values. After staring at them for a few minutes, you work out what they probably mean. Action N means to move north by the beginning. As south is west. L, turn left. Number of degrees. F, move forward. Cool. The ship starts by facing east. Only the L and R actions change the direction the ship is facing. That is, if the ship is facing east and the next instruction is N10, the ship won't move north 10 units but would still move east if the following action were F. How does it happen? But okay. Like ship can swim in the side like a crab. East 10, okay, north 3. F7, so still go to east, yeah. At the end of this instance, the ship Manhattan's distance. Manhattan distance, wow. From figure out where the navigation instruction led. What is the Manhattan distance between that location and the ship's starting position? That's too easy. Break by lines. I guess no reason to create data type for instructions because one letter is instructions, so yeah. So what we want to get is a list of instructs, and each instruction. Okay, let's actually define a parser because we need. Okay, we don't need a parser. Okay, we just head and tail, and head will be the command, and to tail we need to apply read. Okay, so it would be great if there is a function that takes the list of a's and returns a and list of a's. Uncons. Wow, uncons. Because cons is merging arrays, so uncons is demerging them. Maybe. Wow, that's interesting. But yeah, we just use from maybe because we pretty sure that it's just import data list uncons and data maybe, yeah, data maybe from just. So for each of the lines we use uncons from maybe, right? Oh wait, from maybe, no, we need to use from just, right? Yes, yeah, maybe from just map and fmap, and fmap on the pair applies to the second element, read. Okay, instructs. So what we are going to do here, we also specify that we want this to be int, char int, yeah, cool. So our example here is f10. Instructs. Degrees, number of degrees. Wait, can number of degrees be right, 90? Can number of degrees be like, do we need to use cosinus as sinus too? I don't think they do this. Like I believe the number of degrees would be divisible by 90. Okay, so yeah, so we've got instructs. So yeah, what we need to do is to do for del, right? Yes, through instructs, and element is 0 0. I guess let's do it data type. Or what methods will be used with this data type? Actually, not really much methods. We can define like perform an instruction, but I believe it can be done. Okay, we need for each character left and right also different. Yeah, let's create a different data type. Data sheep, right? And sheep will have direction and the coordinates. And what we can is action, do instruction, do instruct sheep. So we have character and int sheep. I guess just type alias will be nice. Is instruct char and int, and here we'll have instruct sheep. Yes, do instruct. So yeah, if instruction is ns, let's start then with f, because it's the simplest one, and distance. So and of course sheep. I don't care, right? X, yeah, it doesn't matter. X, Y, and let's say direction is not a character. Let's say direction is int. Okay, and direction is dx dy. Yeah, so it will have just sheep with the same direction. X plus the x distance. And y please dy dist and d direction. Okay, let's actually not simplify, it will be direction, and let's just make it here. Yeah. Distance direction. Do instruct. That's forward. What if it's left or right? Degrees. Yeah, because we can use cosinus, but I don't see why would you do this. I mean, because we had. Let's just say that. Yeah, so what we are going to do here is degree mod 360. Actually, yeah, we need to have case degree of, and so what here will happen is if degree is 0, then we just return the same sheep, right? Sheep, sheep, yes, sheep. Yeah, I guess having fields is useful. So let's do chords and let's do direction. Sounds good. Chords the direction. Go. Degree sheep, sheep, just sheep. Yeah, basically nothing changed. Okay, yeah. So we can do right then, and say that right is just negative of left. $90. It would mean that we have direction sheep with direction yeah, no direction change. So what we want here is dx and dy, and direction here would be, because we are turning left, so x would be the previous y, or rather minus y, yes, minus y, and yeah, y would be dx. 110 super easy. It's just direction in the opposite. By the way, we are not doing sinus and cosinus because of precision and because yeah, why won't yeah, I guess okay, yeah, we can do cosinus, right? Good point. Cosine, because floating, right? So we will need to round and do this stuff like cosine. Oh, do we have pi actually? Cool. Cosinus pi -1, sinus pi. Yeah, exactly why we don't use it, but it doesn't matter. So probably that's something we can use instead of doing this stuff, right? Okay. Let's actually do it smartly. Okay, L, so degree. Yeah, and how would you convert the x, the y to the angle? Would you use arctangent? And then we'll try to guess whether it's positive or negative? No. Let's go with a simple. We don't need, but we need 270. Because that would be the same as turning right. this would be the opposite. It would be dy. Dy and minus dx. Yeah, nice. Okay, sounds great. So now here right would be everything, everything left, but with negative degrees. So, and now instruct to go east. So, wow. Give me L right forward, so yeah. So direction and distance and ship. Ship, let's say ship x y. Direction doesn't matter, and it will be ship chords x y, and we will add something to x and y. What should we add? Direction multiplied by distance, right? So what we so what we will say is that we have dx, where dx dy how is it called? A world direction, or like a north, south, and so on. How is it called? World directions, or cardinal direction. Don't care. Just direction. Yes. To chords. Let's say direction char to chords. To vector. To vect. Yeah. Character to int. And here char to vec. North equal 0 1. South equals -1. East equals 1 0. West equals 1 -1 0. Dear chair to Vec, and we have dear chair. Sounds good. We have only dx distance plus dy distance. Distance, right? Dy, yes. Sounds good. So that's fold R. So yeah, what we'll do is flip do instruct. Because fold L takes the accumulator from the left side. I don't mean she, that's for sure. Yeah, and we need the first from doing instructs. The first is a primitive ship with east. Yeah, so course would be 0 0 and direction would be 1 0. Yeah, so and we will have ship. So we will need course of this ship, and we will need carry a plus to get a distance, Manhattan distance. Yeah. Doesn't work. It seems like some do instruct has different number of. Yeah, right. Okay. Ship. Right, we cannot use plus here, right? We need to use plus plus. And also here plus plus. Overlapped. Patterns are overlapped. That's interesting. F, L, R. Dir character. Action. Oh, I see. Right. So if we interpret everything as dir characters, then we don't need to do. Yes. That's fine by me. 9. Amazing. Example. So what we are doing here is forward 10. Whew. Okay. North 3. Oh. Okay, should be 10 and 3. Forward 7 should be 17. Yeah, actually let's output what we get. Fold L, you would need scandal. I don't want to do this. Let's just say we have 13 or 14. Let's breakpoint 14. Main example. Yeah, force instruct. No. Result is not the issue here. Instructs is not the issue because there is no variable for this. Hard. But what if we do step? Would it? Okay, string step instruct to ship. Right. Step ship. Oh, actually. Print result. Okay, yeah. Fair, fair, fair. Yeah, sheep. Let's derive. Sure. Wait, why instructs is not in scope? What are you doing? It doesn't matter. Doesn't matter to me. Doesn't matter to me. Let's say 11th. Let's say 13. Right? 23. Oh, I see. Because it's now, and here we have instructs, right? We don't have instructs. Where do we have them? 11. Oh, okay, it's 11. Sorry. 11, 23. Oh, degree ship. Wow. Let's say continue. 9. Thanks. Can I start again? Nice. So what we will do is to print instructs. F and F, F. And that's completely fine. What's not fine is what we are doing with it. There was fold L. Yeah, this one. Okay. Okay, so breakpoint and break 14. Main example, we have instructs. So what we are doing, fold L instructs. $17 money. Okay, that's fun. Yes, not uncarry. Uncar plus on function on uncarry plus and plus should be done on ups, right? Yes, should work. Cool. Puzzle input. Why can't I? Okay, I don't care. Oh, by the way, filter not empty. Right. Lines. Let's see how it goes, and then filter not empty. Maybe just automatically. Cool. Yes, that was too easy. Okay, so do we actually solve the part 2? Okay, a 5-minute break. What's waypoint? Oh wow. Good thing I used waypoints way before this problem. So in the beginning waypoint is 0 0. Mm. 10 units east and 1 units north. Rotate the waypoint around the ship, which is just what I've done. So I just need to change one function, and the direction isn't changing. Wait. We still need. Okay, so it's not chords changed, its direction changed, and so it's not. That's super stupid, but dx dy and ddx and gdy. Yeah. Smart. That's one of the advent of code features that I like. That you need not only solve the problem but make it the architecture good enough to be able to change it to fit the second part of the task. And here I did like amazingly well. Okay, I guess I will break for some time.